Okay, we have an interesting integral from the UNSW Integration Bee 2024. This was round 2, problem 5. We have the integral from 0 to 1 of 1 plus square root 1 minus x squared minus 1 all squared over square root of 2 minus x squared dx. Okay, to get started with it, I don't really know what to do with it in this form. It's a little too messy, and it's making me think we need to do some algebra before we can do anything. Really, what I want to do, we can definitely try to multiply this up, but I want to clean up this part and see if we can get some simplification. So let's just take this and multiply it out, expanding out this squared part. So what's going to happen, we'll write a big square root, then we're going to have 1 minus. Multiplying all this out, we're going to end up with x to the 4th minus 2x squared, and then a plus 1 on the end. Then right away we can see that these 1's are going to cancel off and give us a 0. We'll distribute in the minus sign and rewrite this. So we're going to end up here, this is going to become 2x squared minus x to the 4th. I can then factor an x squared out of this, and what I'll do is I'll take it all the way up, as if we have an x squared inside the square root, that's going to come outside as an x. And so what's going to happen, this all becomes 2 minus x squared. But that's not too bad, because this 2 minus x squared, we notice we have it right here. So let's take this and put it back into the integral, but what we'll do is we'll break it up into two integrals on this plus sign right here. So let's see what happens. So for the first one, it's just going to become from 0 to 1, we'll just have this part here, so it's going to become 1 over square root 2 minus x squared. Then we'll have plus our second integral, and what's going to happen is this again is going to come into the numerator. But now we get the cancellation with this, and all that's left in this second integral is just going to be an x, so we'll use power rule on that. So then come back here and see what's happening. For this one here, what I can do is a trig substitution. I'll substitute, this is in good shape for a sign substitution, so we'll say x is going to be equal to square root of 2 sine of t. I do that because just notice if you square this, when we have x squared, this is going to become 2 sine squared of t right here. Let's take a derivative. So for our dx value, this is going to become square root of 2 cosine t dt. And then here, let's just get our value for t. So rearranging, dividing by square root of 2, we're going to end up with t equal to arc sine of x over square root of 2. So then we'll go ahead with this substitution here. So what's going to happen first, let's update our bounds. You plug 1 in here, arc sine of 1 over square root of 2. That gives me pi over 4 for this upper bound. Plug in 0, arc sine of 0 is just 0. Then where's our dx? Okay, dx is going to be square root of 2 cosine t dt. Here we have 2, we'll use this x squared value, minus 2 sine squared of t. And let's see if we can just finish off this piece down at the bottom here. So first thing that's going to happen, if you factor a 2 out and then bring it outside, that's going to give me a square root of 2 that's going to cancel with this. So I'll just kind of cancel this with this here, and this will just become a 1 right here. Then over here, 1 minus sine squared, this is going to become cosine squared t. But inside the square root, we can actually write this as absolute value of cosine t. But because we're in the first quadrant between 0 and pi over 4, cosine's always positive. We can just drop absolute values. And what that's going to allow me to do is cancel this cosine with this cosine here. And this whole integral just boils down to integrating just 1 dt. So we go ahead and integrate that. And we just evaluate t from 0 to pi over 4. And that's going to give me this part of the solution, which is just pi over 4. And so let's just take this, put it back. We need to integrate x and then finish it off. Okay, so we're almost there. All we need to do is just use power rule on this. I'll bring over this pi over 4. Integrating this, we get x squared over 2, evaluated from 0 to 1. And then, of course, 0 is just going to evaluate to 0 there. So plugging in 1, we get pi over 4 plus 1/2. And I think in the answer key, they put these together. So for my final solution of this, we'll write it as pi plus 2 over 4. Okay, there you have it. Good problem from UNSW 2024. Thanks everyone for watching. Have a good day.